part. First of all, definition of set is, it is defined as well-defined collection of distinct elements. Now, what is the meaning of this definition? It is defined as well-defined, which means it cannot be changed from person to person. Now, it is defined as well-defined collection of distinct elements. तो जो हमारे distinct element का जो collection है, उसको हम set कहते हैं. Well-defined मतलब जो information एक person से दूसरे person तक जाने के बाद भी change नहीं होती, उसको हम well-defined कहते हैं. Suppose we are considering an example. Set of odd natural number less than 10. Now, अगर एक पर्सन इस थियरी को इस तरह से रिप्रेजेंट कर रहा है 1 3 5 7 9, ये सेट ऑफ नेचुरल नंबर्स हैं, ऑड नेचुरल नंबर्स हैं लेस देन 10, और सेकंड पर्सन भी सेम यही चीज लिख रहा है 1 3 5 7 9 सेट ऑफ ऑड नेचुरल नंबर लेस देन 10. तो ये जो इंफॉर्मेशन एक पर्सन से दूसरे पर्सन तक जाने के बाद भी जब चेंज नहीं होती, उसको हम वेल डिफाइंड कहते हैं. तो अकॉर्डिंग टू द डेफिनेशन ऑफ सेट, इट इज डिफाइंड एज वेल डिफाइंड, मतलब जो इंफॉर्मेशन एक पर्सन से दूसरे पर्सन तक पास होने के बाद भी चेंज नहीं होती. It is a collection of distinct element. Distinct मतलब each element is different from the another element. मतलब सेट में कोई भी एलिमेंट एक दूसरे के साथ सेम नहीं होता. तो जो डिफरेंट एलिमेंट्स का जो कलेक्शन है, उसको हम सेट कहते हैं. सेट को हमेशा कर्ली ब्रेसेस के साथ डिनोट करते हैं. एंड सेकंड थिंग इज, उसका जो सिंबल है उसको हम कैपिटल लेटर के साथ डिनोट करते हैं. सपोज इफ यू वांट टू राइट अ सेट, देन दिस इज अ कलेक्शन ऑफ odd natural number less than 10, then this is a set A. It will be denoted like A. Here capital A will be used for denoting the set. So our symbol will be capital A. Now if you want to denote the elements of this set, then that will be written in the A, small b, C, D, E. तो उसको हम स्मॉल लेटर्स के साथ डिनोट करेंगे फॉर राइटिंग द एलिमेंट्स ऑफ द सेट. सो दिस इज अबाउट द डेफिनेशन ऑफ सेट. नाउ देयर आर टू टाइप्स ऑफ सेट. रोस्टर फॉर्म, बिल्डर फॉर्म. और रूल फॉर्म. Its second name will be tabular form. Now there are basically two types of set: roster form or tabular form, or builder form or rule form. Now builder form are, for example, if you are taking an example, we want to write a set, that is set of odd natural number less than 10, then that will be x such that x is a odd natural number less than 10. This is our builder form. Now if you want to write it in a roster form, form. Now let us take the second example. Now for the builder form, if you want to write x such that x is a vowels of English alphabets. X such that X is a vowel of English alphabets. So in the roster form, this set can be written like A, E, I, O, U, because there are 5 English vowels in English alphabets that are A, E, I, O, U. So this is a well-defined set. This is the roster form and this is a builder form. Next is, if you take another example, suppose you want to write that X such that X is a letters of school. Now here, if you see that all the letters of school are capitals. Now here, this set can be written in the roster form, that is S, C, H, O and L. Now here, the letters, all the elements of this set are in capital form, and in the definition of set, we had studied that the elements of this set should be written in the simple form, that is they should not be capital form, but in this our information is given in the capital form. यहाँ पे हमारे जो स्कूल के जो लेटर्स हैं वो कैपिटल फॉर्म में हैं, तो हम इसको कैपिटल में भी लिख सकते हैं और स्मॉल में भी. So this set can also be represent like small s, small c, small h, o and l. One thing should be noted that here double o are present, but according to the definition of set, no two similar elements will be written in the set. So here instead of 2o, 1o should be written over here, and capital letters, as our information is given in capital letters, so we can write it in the form of capital or maybe in the small letters. Both of this representation are correct. Next is concept of belongs to. Concept of belongs to. Now, what is the meaning of this belongs to? Suppose we consider set A, E, I, O, U. In this set, when you are representing a set, here all the elements are distinct and all these elements are differentiated by introducing comma among all of them. अगर हम किसी भी सेट को रिप्रेजेंट करना चाहते हैं तो उनके एलिमेंट्स में हम कॉमास भी इंट्रोड्यूस करेंगे उनको डिफरेंशिएट करने के लिए. दैट इज, अगर ए और ई दो डिफरेंट एलिमेंट्स हैं तो उनको डिफरेंशिएट करने के लिए बीच में हम कॉमा लगाएंगे. सो सभी एलिमेंट्स में कॉमा इंट्रोड्यूस करेंगे. Now concept of belongs to. Let us suppose this is a set A. So if I want to write that A belongs to A, then it will be written like A belongs to A or E belongs to A, but B does not belong to A. Now what is the meaning of these steps? Now here A is present in this set. Similarly, E is also present in this set. That is, A और E जो हैं वो इस सेट के एलिमेंट्स हैं. तो हम कहेंगे कि जो एलिमेंट्स इस सेट में प्रेजेंट हैं तो उनको हम कहेंगे कि ये सेट जो है ये जो एलिमेंट है इस सेट को बिलोंग करता है. सिमिलरली E इसको बिलोंग करता है पर B एलिमेंट इसमें प्रेजेंट नहीं है. This is a letter of English alphabets, but this is not a vowel of English alphabets, and it is a set of English vowels. तो इसमें B present नहीं है, तो so B does not belong to A. Let us consider one more example. Suppose I am taking one more set. इसमें हमारे पास बी सेट है, तो बी सेट में सपोज कुछ एलिमेंट्स हैं, जैसे एक फैमिली है मिस्टर शर्मा की फैमिली, तो उसमें जो मेंबर्स हैं दैट आर रीता, गीता, सीता और उसके मदर फादर। तो इसमें अगर मैं कहूँ कि एक मोनू पर्सन है जो इस सेट को बिलोंग करता है कि नहीं करता, तो अगर जो मोनू है तो मोनू डैश बिलोंग्स टू बी और नॉट, इट डज नॉट बिलोंग टू बी। क्यों? क्योंकि उसकी फैमिली में यही मेंबर्स हैं, मोनू इस फैमिली में नहीं है, तो ये इसमें बिलोंग नहीं करता। पर हम अगर रीटा की बात करें तो रीटा इस फैमिली की मेंबर है, इस सेट में वो बिलोंग करती है, तो रीटा बिलोंग्स टू बी। सो दिस इज द कॉन्सेप्ट ऑफ बिलोंग्स टू। Now we will do some definitions of the set. Now let's continue different types of set. Set of natural numbers. Set of natural numbers are denoted as capital N, and these are starting from 1, 2, 3, 4 up to so on infinity. That are the also termed as positive set of positive integers, or this set is also called countable set. That is the numbers which can be counted. So here 1, 2, 3, 4 up to so on infinity are the set of integers. Now next is set of whole number. Set of whole number is denoted by W, that is starting with 0, and rest is set of natural number 1, 2, 3 up to so on infinity. This is a set of whole number. Next is set of integers. Set of integer is denoted by Z, and minus in infinity dash 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 minus 5 minus 4 minus 3 minus 2 minus 1 0 1 2 3 up to so on positive infinity. This is a set of integers. Next is set of rational number. Rational numbers are denoted as Q. Now this can be represented as, the numbers of rational numbers can be represented in the form of P upon Q, such that Q is not equal to 0 and GCD of P and Q is equal to 1. So this is a definition of rational number. Next is set of irrational number. Set of irrational number are denoted as capital T, but it has no set. That is, these two sets cannot be represented like this. But in a general form, we can say in a similar way like this. This is a set such that P and Q belongs to some integer. In a similar way, the set of irrational numbers are those numbers which are not rational numbers. For example, these are like root 3, root 5, root 7. These are the irrational number. Next are set of real number, that is denoted as set of real number. Set of real number is denoted as capital R. Now here two types of subsets of real number are positive real number and negative real number. Now first of all, what do you mean by real numbers? The numbers which are lie on a real number line. Suppose you are considering a coordinate axis. Now here the numbers which are lying on this line, this is called a real number line, and this is called a complex number line. This is a complex number line. This is a real number line. The point of intersection of these two axes is called origin. So the numbers which are lie on these line is called real number lines, and the set of these real numbers are the real number set. Now in this real number set, all these sets are included because all these elements are lying on this line. So this is also called as a superset of all the sets. That is, all the sets are lying in this set. One can say this is a bigger set among all these sets. So this is a bigger set. Now let us understand the concept of builder set form and roster form by considering these examples. Now first of all, write the solution of the equation x square plus x minus 2 equal to 0 in the roster form. Now here we want to find the solution of this equation in the roster form. That means this is already in the set builder form. So this is a set builder form equation. Now we want to find the solution of this equation. Firstly, x square plus x minus 2 equal to 0. This is a quadratic equation. So we will apply the middle term splitting method over there to find the solution of this equation. Now x square 1 into minus 2. Coefficient of x square is 1. So 1 multiplied by minus 2. That will be minus 2. So after addition or subtraction we should have 1 and multiplication with minus 2. So x square 2 into 1. 2 multiplied by minus 1 will be minus 2 and 2 minus 1 will be 1. So all these conditions are satisfied that after multiplying we should have minus 2 and after addition or subtraction we should have plus 1. So both these conditions are satisfied. So plus 2x minus x minus 2 equal to 0. X plus 2, taking x common to the both of these terms. From here taking minus 1 from these two terms. So we will left with x plus 2 multiplied by x minus 1 equal to 0. Now this is a factorization form of this equation. So we will have either x equal to minus 2 or x equal to 1. So the solution of this equation is minus 2 and 1. So this is our roster form. This is our set builder form and this is our roster form. So in the now here value of x is minus 2 and either minus 2 or 1. So here this is a solution of this equation. That means if you want to find this equation in the roster form, that is, it is understood that this is a set builder form. Now let us consider next example. So write the set x such that x belongs to set of positive integer. Here z plus means set of positive integers and x here is less than 40 in the roster form. अब हमें set builder form दी गई है, क्योंकि अगर हमें रोस्टर फॉर्म निकालनी है तो हमें कोई सेट दिया हुआ है, तो दैट मीन्स ये हमारी सेट बिल्डर फॉर्म है. और सेकंड थिंग, अगर हमें कुछ डिफाइनिंग फॉर्म में सेट दिया हुआ है तो हमने उसको सिंपल फॉर्म में सॉल्व करना है. दैट मीन्स वो जो सेट है वो सेट बिल्डर फॉर्म है और हमें उसको रोस्टर फॉर्म में निकालना है. नाउ So we have a condition in set builder form कि हमारे पास जो elements हैं वो positive integers हैं. Second thing, जब हम उनका स्केयर करेंगे तो उनके जो स्केयर की वैल्यू होगी वो 40 से लेस होगी. Now let us consider. First of all, set of positive integers will be 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square and so on. Now after solving 1 square we get 1, 2 square will be 4, 3 square will be 9, 4 square will be 16, 25, 36, 49, 64, 81 and 100 up to so on. Now up to infinity. Now we want to find the square of those numbers which are after scaling up to less than 40. So here less than 40 are these squares numbers. So that means square up to this we want to find the square of a number. So 36 is 6 square. So that means x जो हमारे पास एलिमेंट्स हैं वो हमारे पास 6 स्क्वायर तक हैं, अप टू 6 स्क्वायर, बिकॉज आफ्टर दैट 49 जो है वो 40 से ग्रेटर हो जाता है, पर हमें जो वो वाले एलिमेंट्स का सेट चाहिए जिनका स्क्वायर 40 से कम है. तो एलिमेंट्स विल बी 1 2 3 4 5 and 6. So this is our roster form. That's all. Now in this example, it is given that set A equals to 1, 4, 9, 16, 25. That is, it is a roster form set. Now we want to write in a set builder form. Firstly, if we look at this set, here set A is 1, 4, 9, 16, 25. That means this is a square of natural numbers. Now 1 square, 2 square, 3 square is 9, 4 square is 16, 5 square is 25. So this is a square of natural number, set of square of natural numbers less than 6, because 6 square is 36 is not included in this set. So this is up to 5. So square of natural numbers. So this set in a builder form can be written like x such that x equal to set of natural number and n belongs to some natural number set. So here n is greater than equal to 1 and less than equal to 5. So this is a set builder form. So that's all. Now let us move to the next example. Here we are given a roster form of a set. We want to write it in a set builder form. So if we look at the set, then it is 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7. Now if we look it carefully, then in the denominator and in the next numerator, now elements are same. Similarly here is 3 and here numerator is also a 3. 4, 4. 5 is here, 5 is here, 6 is here, 6 is here. Second thing is that denominator is 1 more than the numerator. Here numerator is 1 and denominator is 2. That means 1 more than numerator. Here denominator is 3, numerator is 2. That means 2 plus 1 is 3, so 1 more in the denominator. So we can write it as n upon n plus 1 such that n belongs to natural number and n lies between 1 to 6. So this is a set builder form. That's all.